Hello, today we are looking at encrypting data and we're going to look at some Python code to demonstrate that, and I'm using for reference sailor.org, which I mentioned in a previous video, which I think is a really good source of information. So what I want to do before we do this is actually describe the concept using bear with me. So what I've got here is an analogy of how you might go about sending something securely. So let me just get rid of my ugly mug. There we go. What we have here is we've got Jack the bear, and he wants to send something, some treasure, securely to his plasticine friend over here on the right with the yellow key. So Jack's got the red key and the red padlock. What he's going to do is he's going to attach his red padlock to the treasure chest. Okay, so that's quite straightforward. He's going to lock the treasure chest, and then he's going to send it. He's going to send it via, DHL, parcel force, whatever, UPS. Then, when his friend gets it, it's still going to have his padlock attached, which is a problem because it means that his friend can't open it. So, what you do, you attach a second padlock. You think, well, that's making it even worse. How's that going to work? So, you attach a second padlock that you have the key to. So now it's locked twice. It's locked with the red padlock. Jack has the red key. It's got the yellow padlock, and this plasticine friend has got that. So then what happens is this plasticine friend sends it back to Jack. Sends it back with two padlocks on. So it's still secure, it's still locked. Next, it arrives back at Jack's house. It's got two padlocks on. Jack has the red key, so Jack can now remove the red padlock. He's taken it off. Now, the treasure only has the yellow padlock on it, so Jack can now send it back to his plasticine friend. Goes in transit, still locked with the yellow padlock. His friend gets it. It's still locked, but it's got a yellow padlock on. Now, that means that it can be unlocked with the yellow key. The yellow key takes off the yellow padlock, and you've got the treasure. Okay, so let's do this example. So for this example, we'll use Python cryptography library called PyCryptodome. It's got an X on the end, which shouldn't be there, don't worry. So pip3 install PyCryptodome. That's the package there, so you can do a pip install. Then import the functions we need from crypto.cipher. Import pkcs1_OAEP. From crypto.public_key, import RSA. From Binaski, import hexlify. You'll need to do pip install Binaski if you don't already have it as well. So now let's create a message to encrypt. So let's go back to the terminal. So I've just done what you saw there. From crypto.cipher, import pkcs1_OAEP. From crypto.public_key, import RSA. Then you may need to install this if you don't, well, you will if you don't have it already as well. Binaski, import hexlify. There we go. I love cryptography. Private key equals RSA.generate 1024. That's generated a private key, so we also need a public key. So we derive the public key from the private key. So the private key that we created here then gets used here, and we derive the public key from that. So far so good. We can also print these objects out at this point to be sure that we are expecting, they are what we're expecting, which is class crypto.public_key.rsa.rsa key. So let's just In fact, because we're using IPython, we don't even need to use print. We could just do this. And that's what we expect to see. Now we'll convert our keys to strings, save them in PEM files, and take a look at them. So let's go with, I'm just copying these from sailor.org. I'm not pretending to be doing this all from scratch. What I am doing is I'm demonstrating the tutorial. So there we go. We've got private key export key decode and public key export key decode. So that's turning them both into strings. Now they're both strings, what you can actually do is you can just private PM, and then you can do public. So safe to say we've actually created them. And then we can write them both to files. So I'm just going to copy that because you don't want to watch me type it all. So if we just do clear, paste in the commands to write them to PEM files. Don't worry about the caret symbol, it still works. That's just because I've copied and pasted it. So we've written those two keys to files. Now what we want to do is we want to read those back out. So if you're familiar with Python read function, we're just going to read those files back into the variables. So PR underscore key, we read the contents of the private key, and PU underscore key, we read the contents of public.pem. We import those two keys. So if we want to check on them again, notice how these are different names to what we previously had. So you can't just use the same variables as before. PR underscore key, PU key. So we've got a pair of keys. That's good. That's what we would expect to see. So now we want to create, now the encryption. Remember, data is encrypted with a public key and decrypted with the corresponding private key. So we encrypt with a public key. So this is what we now do. And cipher equals PKCS1. So that's the encryption method algorithm. And then we just say .new key equals PU key. So cipher underscore text is a variable which will contain the encrypted message. So if we do cipher underscore text, now we see the encrypted message. So now what we want to do is we want to use our private key to decrypt the message back to its original form. So we create a variable called decrypt. And then what we'll do is we will make it equal to PR private key. So the decrypted message will be PKCS, the algorithm, .new, and the key is the private key. So we're saying use the private key to decrypt the message. And then if we do decrypt, we need to say decrypted underscore message equals decrypt dot decrypt. And then we just want to display it. I love cryptography. If you see your original message, congrats, you've completed the first exercise, you're done. So that was a demo of how to encrypt using the public key and then unlock with your private key. So data is encrypted with public key and it's decrypted with private key. So don't expect you to learn all that off by heart first time round, as I didn't. So hopefully that's given you some inspiration. This channel's all about giving you inspiration to learn new things and expand on what you already know. Surely that must be a good thing, surely. So on that note, see you next time.